This is AS1 January 09 question 2. Figure 2.1 shows a player in a darts competition, and you can see the man standing here. This is a dartboard. There's the centre of the dartboard is the bullseye, and the bullseye is 1.7 metres above the ground, and the distance the man standing from the board is 2.37 metres. It tells you then the player stands at a white line on the floor 2.37 metres from the board. The bullseye on the board is 1.7 metres above the floor. Figure 2.2 is down here. It shows the bottom segment of the board. Depending on the region of this segment into which the dart sticks, it scores 3 points. So these two bits here score 3 points, or multiples of 3 points. So this small area here scores 9 points, treble 3, and this one is double 3, which scores 6 points, this larger one here. Standing at the white line directly in front of the board, the player throws a dart horizontally from a point 1.7 metres above the ground at the same level as the bullseye, with a speed of 14 metres per second. Calculate the time taken for the dart to travel between the player's hand and the dartboard. Ignore air resistance. Okay, so we have a bit of information there, and we have enough information to calculate this using our horizontal components. And our horizontal components, all that we need to know are a speed, which we do know, which is 14, because he throws the dart horizontally, so he throws it with a speed of 14. We know the distance it travels, so the distance it travels is 2.37 metres. And we're looking for time. So time is distance over speed, and that's 2.37 divided by 14. And the time that you get is 0.17 seconds, rounded up to two significant figures. The dart sticks into the board at the point marked A on figure 2.2. Calculate the vertical distance y of the point A below the centre of the bullseye. We have a wee look at that. You can see there's the bullseye, and we know that that's at a height of 1.75 metres. And what we need to know there is this distance A that it actually sticks into the board. So he throws the dart horizontal with the bullseye. He's thrown the dart horizontally with the bullseye. He throws a dart horizontally from a point 1.75 metres. So what actually happens here, and I'm going to draw this on, if point A is there, then the dart goes like that. So that's part of a projectile motion there. And so what we need to find out is what is this distance here, this one here, this vertical distance that the dart decreases its height by, and that will give us the answer y there. That's that answer y. And so to do that, if we write down the things we know there vertically, so this is a vertical component we're going to use. So vertically, we know that its initial velocity is 0. We know that the time that it takes is 0.175 seconds, 0.17 seconds, sorry, from the answer above here. And we know that it's subject to acceleration due to gravity, so an acceleration of 9.81. And we want to know the vertical distance that it falls. And so using S equals ut plus a half at squared. That gives you 0 for the first bit plus a half times 9.81 times t squared is 0.17, and it's squared. And that gives you an answer of 0.14 metres. So the dart falls a vertical distance of 0.14 metres, and that's there. And if we have a wee quick look at the diagram up here too, that's that distance there as well. The player now needs a double 3 to win the game. Without further calculation, indicate by placing a tick on the appropriate box how the projection speed should be adjusted to achieve this result. The dart is to be thrown horizontally towards the bullseye as before. Explain your answer. So we'll have a wee quick look at this and just see. He needs a double 3, and the double 3 there you can see is at the bottom. So what he needs is that vertical distance, and I'm just going to draw it in here, has to be a little bit more like that there. He has to do that. Okay, that means that the vertical distance that the dart falls has to be greater. So it has to fall further there. So if we have a wee look here, I'm just going to write that down. First of all, to hit a double 3, the vertical distance y must be further or greater. So the thing that can change in your equation to calculate that, we used s equals ut plus a half at squared. So if this is going to be greater, and that stays the same, that's not. So that's the same, and acceleration is the same. The only thing that can change is the time, and therefore the time must be larger. So time taken to travel, greater vertical distance must be greater. Greater vertical must also be greater. And then since the horizontal velocity depends on the distance it travels over the time, so this is a horizontal distance which is at 2.37 metres, it's staying the same, and this time is greater. No, sorry, if that horizontal distance is the same and this time is greater, that's right, then the horizontal speed must be smaller. So the speed must be smaller. And that's the answer. So the speed of the dart should be decreased, is right. And that should make sense to you. If you want to make sure that your dart, when you're throwing it, hits higher up, you'll have to throw it a wee bit faster to make sure that it isn't being influenced as much by acceleration due to gravity. It has to move a bit faster. Last part of that question then. The player changes the type of dart used to one which is a greater mass and throws it in the same direction, but with the same speed as the dart which hits point A. Describe how the position at which the dart strikes the board will change, if at all, as a consequence of the change of mass of the dart. Explain your answer. Now, the mass of the dart is irrelevant, and the reason is that the mass of the dart is independent the mass of the dart is independent of the final speed, and that's only that's only affected by acceleration due to gravity. And therefore, if it's independent of the final speed, it's also independent of the distance travelled. Final distance and the distance travelled. You can't see that. Mass of the dart is independent of the final speed, but also in this case we're wondering about the distance travelled. Acceleration due to gravity stays the same. So it's affected by acceleration due to gravity. And therefore the box that you're going to tick is that the dart strikes the board at the same place, and that's A.